Alright, so these are the equations we're going to use. These two equations, the ones that started off, they're going to help us decompose our vector. That means we're going to take our launch angle, and we're going to say which part of this launch velocity is going to pushing the projectile sideways, and how much of it is going to pushing the projectile upwards. You know, the Pythagorean sum is the vector that we were given of 26. And so we can work these through really quick using our calculator, and we can say v naught equals 26 times the sine of theta, which gives me a number of 22.5, or in this one, times the cosine of 60 gives me 13. I can use this formula, v final y equal v initial y plus at, to tell me how long it takes for the ball to get to its apogee. So 0, which is the y-speed at apogee, is equal to 22.5 plus a negative 9.8 meters per second squared times time, or 22.5 over 9.8 gives me the time to apogee, which is 2.29. So let's call it 2.3 seconds. Okay. So it takes 2.3 seconds for me to get to the top of my projectile motion. That doesn't, it's a whole flight though. The whole flight is twice as long because the time it takes to go to the top is the time it takes to go back to the bottom. So my total time of flight is equal to 4.6 seconds. Now the x velocity doesn't change at all when this projectile is flying. That's because there's no air resistance. So I can just use the formula distance equals rate times time, or delta x equals v naught xt, which is the same exact statement. Delta x being a distance, v naught x being a speed, and t being a time. So I can say delta x equals v naught, we have up top, is 13, and time is 4.6 seconds. Alright, well that's pretty nice. 13 times 4.6, that comes out to 59.8 meters, which is my final answer for this problem. So in other words, when I fire this gun, in an idealized situation, it would fire a golf ball just about 60 meters, or, you know, a little farther than half a football field. So that's the first one. Alright, let's look at problem number 1. It reads like this. A golf ball gun can launch at 26 meters per second. If I launch a projectile at an angle of 60 degrees, find the maximum horizontal range of the gun. Assume air resistance is negligible and that you're on Earth. Round your answer to the nearest tenth if needed. Alright, so let's write down some of what we know on this. We know that v naught is 26 meters per second. We know that, well, ay, the acceleration in the y direction, is gravity, 9.8 meters per second squared. We know that ax, because we're ignoring air resistance, is 0 meters per second square. And that's just about it. The only other information we were given is our projection angle, our launch angle of theta, is 60 degrees. Alright, so what this basic problem's outline is let's say I've got some ground here, and I've got a gun, and that gun is terrible. Let's try again. Much better. I have a gun at an angle of 60 degrees, and it can launch a projectile at 26 meters a second, or about, 50, 60 miles an hour. As it launches, it will shoot that projectile in some parabolic trajectory, which is symmetrical if I've drawn it right. And from where the gun was fired to where the gun's projectile lands, we can call that delta x. Alright, the trick to this question is knowing that at apogee, which is to say at the top of this flight, the motion is only horizontal. Another way of saying that is Vy, the velocity at y at that instant, is equal to 0 meters per second. So I can solve the time it takes to go between the launch and the apogee. That is to say, the time it takes to go in this area, by just saying I start at v naught y and go to 0.